Yes. So in our previous sessions, we have started with the discussion of our what do you mean by an interface, how you are going to declare your interface, and how you're going to use your interface. This and all things we have started our discussion, and also we have seen a case where we can use our interface, like how to use our interface. We have seen one particular case, right? So is it clear? Like, have you watched the recordings, or if you have joined live, is it clear? Any doubts or any queries in this interface related concept? Yeah. 1 minute. Give me 1 minute. Yeah. So I hope everything it is clear. So let us start this session. So in the previous session, we have seen one particular question that what if our interface is going to in the previous problem we have seen that interface is not going to have any input and output directions for the signals. What happened to this? 1 minute. Problem where we haven't given any directions to our interface signals, and we have seen that particular example, right? Now let us continue with that particular discussion. So let's say if I am having the interface declared over here, I've just declared my signals, that's it. The valid signal, w data signal, all the signals I have declared, but nowhere I'm providing the directions to the signals. Okay, so let's see this, how to provide the directions to this interface signals. Let us try to understand. So we are going to use something known as mod port. So using this mod port, we are going to provide the directions to our interface signals. So this mod port is going to provide, or it is going to decide the directions of the signals. Okay, whatever the signals which we have in our interface, that we can give the directions using this particular mod ports. Okay, mod port here it is a keyword which we are going to use. Okay, now how to provide the directions? Let us see. So I'm going to write the interface for the previous example only, which we have used in our previous session. Interface INF is my interface name, and the valid signal. Let me declare all the signals: logic, valid, and I have W data signal. Okay, and what are all the signals I have? Valid, W data signal, ready signal, write signal, R data signal. Logic, ready, and our data signal. Let's say we have this particular signals. Okay, and now before that, this is my master again, and this is my slave. Okay, so this master is going to give you the slave valid signal, and the slave is going to give the master a ready signal. Okay, now I am going to write down mod ports for master and mod port for my slave. So how I'm going to write down in the interface itself, I'm going to write down mod port, and the mod port name is master underscore mp is my mod port name, and here I'm going to give the directions. Now with respect to master, what is the direction of your valid? It is output, so I'm going to write down output valid. And with respect to my master, what is the direction of your ready signal? It is input, so I'm going to write down input ready. So this is how I'm going to give the directions. And if I'm going to write down the mod port for my slave, what I'm going to write down? Mod port slave underscore mp, and with respect to my slave, valid is my input, so input valid and output ready. So this is how I'm going to give the directions with respect to my uh with respect to my module. Okay, followed by end interface. That's it. Is it clear, guys? Yes or no? How to provide the mod code directions with respect to your module? Are they clear? Any doubts or any queries in this? Yes, no, clear, not clear. Okay. Yes, that's great. Okay. Let's see one example of using our modport. Let's see one example. Hope my screen is visible. Yeah. So declared a, let me write down a simple interface. So what I'm going to write down interface. Let's say the interface name is INF. Okay. And in this interface, let me use few signals. Logic A, B, C are my signals. Okay. Uh, or else let us take ready and valid only. These are my signals which I'm going to have. And with respect to my master underscore NP, ready is my output and valid is my input. Okay. And with respect to my slave underscore MP, uh, input is my valid, sorry, input is my ready signal and output is my valid signal. Okay. Sorry, I think I have given the in the reverse direction. This is input and this is output. According to our specification, I'm giving them. Okay. And this is input and this is output. Okay. Now that's it. And followed by end interface and valid. I should give, and that's it. And followed by end interface. End interface. Okay. Now, so let us write down a simple module talk, or let us first of all write down my master, which is having a argument which is intf interface name followed by master underscore intf is the handle name which I'm going to have. Okay. Now here within an always block, okay, always at the rate star I'm going to use. Okay, always at the rate star, which I'm going to write down over here is, or let's say within an initial block, I'm going to write down. Since I haven't using any clock, I'm going to write down within an initial block. I'm not planning to synthesize it. Okay. So what I'm going to write down is if I master underscore intf dot ready, if it is equal to 1, then what I'm going to do is master underscore intf dot valid is equal to 1. Okay. This is simple code. Or let's say let me take one more signal, logic master underscore done and slave underscore done are my signals. And output master underscore done is output to my master, and slave underscore done is output to my slave underscore done output slave underscore done. Okay. Yeah. Mhm. So here I am going to write down master underscore done. Okay. mast underscore done. That's it. Okay. And followed by end this block and end module. Simply I'm going to write down for the slave also what I'm going to write down. So module slave, it is slave underscore intf, and let me copy this handle name, and here I'm going to write down slave underscore intf dot ready if it is slave dot intf dot valid if it is equal to 1, then I'm going to make my ready is equal to 1. Some code I'm writing. Okay. And here let me mm, make my valid also equal to 1 initially. Master underscore intf dot valid is equal to 1. Okay. Yeah, this is the simple code which I've written. Okay. Is it clear, guys? Any queries in this code? Simple code. Just I've created a interface and I have ready and valid, master done, slave done. So in this, ready is my input to my master, output is valid, and master underscore done is also one of the output. And slave underscore modport, ready is input to your slave and output to your master, and valid is input to your slave. Okay. Now, what I'm doing, I've created a master model where I'm basically making my valid to 1 and waiting for the ready signal. If it is equal to 1, then I'm assigning master underscore done is equal to 1. And in the slave, I'm waiting for the valid signal. If it is given, then my ready equal to 1. Is it clear? Interface name is INF. Okay, sorry. Yeah. Is it clear now? INTF. Okay. So is it clear? Shall we move forward? Anyone needs this code explanation again? Okay. Okay. Now I'm going to take a top model in this top model, what I'm going to do is I'm going to first of all create the instance of my interface. I need to create the interface instance. How to create the interface instance? Interface name followed by interface instance name. How to create it? Let's say it is master underscore inf is my interface instance name I'm creating. And okay, for master and slave, I'm going to have only one interface only, right? So let's say it is inf is my interface instance name. Now let me create the instance of my master. How to create it? Master instance name, let's say m. Okay, and I'm going to pass this instance inf, and slave, let's say it is s, and I'm going to pass the instance. That's it, and followed by end model. That's it. Is it clear? Any doubts or any queries in this? Just simple code where we have created. Where? Okay, okay, okay. Sorry. Let me check for any spelling mistakes also. INTF. Yeah. Okay. Yeah. So let us check what is that we are going to get. We are not displaying anything. Uh, master underscore INTF. Where is 74? Sorry, this is slave. Slave underscore INTF. Yeah, that's it. So we are not going to get any error. Yeah. And we are not displaying anything. Just I'm showing one particular example of using your interface. Okay, guys, is it clear? How to use your interface? I hope in our previous session also we have seen one example of using your interface, right? Yeah. Any queries or any doubts in this? Please let me know. Okay. Now, let's say here ready is input to your master. Can I write? Can I write like this? What I'm going to write down is master underscore intf dot ready is equal to 1. Can I write like this? Is it a valid thing? Ready is input to your master, but what I'm writing, I'm driving the value to ready. Is it a valid thing to do? If you have a input to your module and can you drive any values to that input? No, right? It's logically wrong because it's input to your module and you cannot drive any values to that particular input variable. Am I right? Yes. Now let us try to do the wrong thing. Let us try to no, no, not only in the top. If you have any input signals, you cannot drive any values to that particular input signals. Okay. So let us run this. Let us see what is going to happen. Are we going to get any error? Let us check it out. Are we going to get any error over here? No error if you carefully observe. Okay. So if you try to drive the values to your input variables also, you're not going to get any error. Okay. So to restrict this particular usage, okay, to carefully restrict and to carefully protect without for avoiding driving your input values, what we are going to do is we are going to use the mod ports. So what I'm going to do here, master underscore mod port. I'm going to have interface dot master underscore mod port. Let me run it again and let us see what is now we are going to get. See, now we are going to get a error saying that port ready of mod port has been restricted as an input port. Input ports cannot be driven. So what we have done here, previously we have simply written interface. Now what are we writing? Interface dot mod port. So that we are accessing the mod port and this mod port will help us to restrict the driving of any values to the inputs. You can see over. Accidentally, if we are trying to drive any values to the inputs, this mod port will help us to restrict that particular thing. Is it clear for everyone? Usage of mod port, is it clear for everyone? Okay. So if you have any particular module like this, if you have a module like this, yeah, here master. Master is basically having this ready as your input. In the master, we have the signal ready declared as input. You cannot drive any values to this ready. Like you cannot write down ready is equal to 1 or ready is equal to 0. No, you cannot drive any values to the input signal. Okay. But if you are not including this particular interface dot modport name in your arguments, then what is happening? You can able to drive the signals, which is basically input to supposed to be input to your master. Okay, you're not going to get any error. But if you are using interface also, sorry, if you are using your mod port also, then mod port will help you restrict the driving of your input ports. See, you are going to get an error saying that you cannot drive the values to your. Now is it clear, Bhuvanesh and others? So this is where we are going to use our mod ports, not only for giving the directions, but also to avoid the accidental driving of your input values. Okay, it will make sure that you only drive the output values, but not the input values. So mod port will help you to restrict that particular thing. Okay, so this is where you can use your mod ports. Okay, and in the slave also, if you you can also write down intf dot, and for the slave, what is the mod port name? We have slave underscore mp. So we are going to write down slave underscore mp so that it will only restrict. It is going to restrict the usage. It is going to restrict driving of your input values, and it will only allow driving of your output values. Okay. Yes. Is it clear, guys? Are you following me? Okay, that's great. Yes. And here, our interfaces can also have tasks and functions declared inside them. Okay, let us see that particular thing also. Okay. So how to do that? Let us see. So here we are going to have a task. Where is it? Yeah. So this particular example we have taken. So we have simply declared a interface over here. Let me uncomment this code. And let me comment to the below part. Yeah. So we have a particular interface, and here we have a task which is display. Okay, and I'm just writing hi. Okay, and I have a module which is example, and here what I'm doing, I'm basically calling this task using the interface. Okay, that's it. So if you have declared, you can think of having a common task which should be used in multiple classes or multiple components. You can declare it in interface and you can use it across different modules. Okay, so it will be helpful when you declare your task inside your interface. Okay, let me print it. So you're basically getting hi. So how to print this particular task? You are going to print this particular task using interface name dot the task name, which is nothing but display. Okay. Yeah, it is allowing if you're not using mod port, but if you are using mod port, it is restricting. That is what I've shown you, right? Input driving is allowed when you're not using a mod port, but if you are using a mod port, just now I've shown you, right? So it is not allowing it. Have you seen it? Let me show you one more time. So what is my input is ready. So what I'm going to do is mast underscore intf dot ready is equal to 1. Okay. So it's an input port. It should not be driven. Okay. But let's see if we are driving it, we are going to get an error. But if we are removing this mod port, then it will allow the driving. Okay. So that's why mod port inclusion is important over here. Okay. Yeah. Now, now coming to this tasks and functions example in your interfaces. Let's see one use case over here. Where is it? intf dot mast underscore. Sorry, what is the mod port name? Mast underscore mp. Okay. Yeah. Now let's include one task over here, which is display. Task display, and this display task is basically going to display calling task display. This is the display task which I'm going to have. Okay, and followed by end task. Now here I'm going, if I want to call this particular display task using my master, how to call it? Simply call it by mash underscore intf dot display. Let us see whether it is being called or not. See, so task display of interface INTF cannot be accessed from instance master underscore INTF or modport. To access this task from modport instance, import or export the task in modport prototype. So if you are going to have a task declared, then you need to include it in your modport, or else remove the modport instance in your argument, then you can call your task. Okay. So let me show you again. If I have removed the modport instance from my argument, then it is running normally only, and we can able to call the task from the module, which is my master. But if I have declared my modport instance with my interface.modport in my argument, then I need to import this particular task in my modport. How to import it? Let us see. So I need to write down import task display. Then only we can able to call this task. Let us see how to call this task now. Sorry, import task display. I need to have this. Yeah, let us see now. Ready. Okay. See. So calling task display. So if you have an modport instance declared inside your argument, then you need to import that particular task inside your modport so that you can use this particular task display. Now from the slave, let us try to call this task. Let us try to call this task. So how I'm going to call this task? Slave underscore intf, slave underscore intf dot display. If I'm going to call this particular task, let's see what is going to happen. See, I'm going to get an error saying that display is not accessed from the instance or mod port, because we haven't imported that particular display task in my slave mod port, right? So that is why slave module cannot access this particular task. So if you carefully observe from this particular discussion, the conclusion over here is you can also restrict the access. If only one particular module should have the access to this particular task which has been declared inside the interface, you can do that. Or else, if let's say if master and slave wants the access to this display task, then include it in the mod port. Okay. So if you make the changes in interface file itself, that's enough. Any module can access it, or any module can be restricted without accessing it. Is it clear, guys? The usage of mod port, is it clear? Any doubts or any queries? Others also, please let me know if you have any doubt. I will try to clarify it.